All right, now, unit circle day. This is the beginning of trig. And this is the classic beginning of trig, because I want you to learn trig the right way. And the scary part is if you learn trig the right way, you're going to find out that if you do not memorize, learn, memorize to get short-term learning that leads to long-term learning, the part that we do for the next couple days, then you will never be able to do trig. Because everything in trig is going to relate back to this thing called the unit circle. Okay? The unit circle is based on the formula x squared plus y squared equals 1. That's what the unit circle is based on. It's based on that formula. So the center is at 0, 0, and the radius is 1. So this point right here has to be 1, 0. This point up here has to be 0, 1. And needless to say, there's a point back here, negative 1, 0, if you have the whole circle, which we're going to do the whole circle tomorrow. Today we're just going to concentrate on this quadrant. And then you'd have a point down here, because the circle goes all the way around, but for today, just quadrant 1. Now, in quadrant 1, you already know that the x value and the y value are both positive. And somebody says, why is he writing that up there? Because I don't trust you to remember that. Hate to say it, but don't. But that is. In quadrant 1, they're both positive. Now, from that, we're going to go back and talk to you about geometry. All right. In geometry, you had this triangle that was called a 30-60 triangle. And you learned some rules about that triangle. Those 30, 60, 90 triangles. You learned some rules about those. And if you have the hypotenuse right here, you learned that the side of 30 degrees always had a special relationship to the hypotenuse. Does anyone remember what it is? It's all right if you don't. It's the only one you have to remember for the future, because the 60 degree one we can figure out, but we got to know the 30 degree one. Anyone?
Are you talking about the base?
Yeah. Right here.
It's square. It's half as long as the hypotenuse.
Very good. Who said that? Yes, sir. This side over here is always half of whatever the hypotenuse is. Now, if you don't know how this side relates to hypotenuse, it's okay. I'll show you how to figure it out. This side squared plus this side squared has to equal the hypotenuse what? Squared. The one you have to remember is the 30 degree when the opposite of it is always half the hypotenuse. Then you can figure the other one out if you need to. All right? And the way to figure it out is to simply go x squared plus 1/2 h squared equals h squared. X squared plus 1/4 h squared equals h squared. X squared equals 3/4 h squared. So x is equal to the square root of 3 over 2 times whatever the hypotenuse is. This side over here. All right? Now, if you don't see, and this one's hard for me to remember. I never remember this one. But please always remember the one opposite 30 degrees is what? 1/2 of the hypotenuse. Now, that's our little memory of 30-60. Okay. And you're probably going to want to draw maybe 3 different little first quadrants as we do this, because we're going to talk about 3 different angles. But this one should work pretty good for you. I'm going to start here at the center. Get rid of my compass. Make this entertaining for the children at home. Don't interrupt. I think I won't hear you. Hope you didn't pick that up. All right. I'm going to come up from here at 30 degrees and go out. come up from here and go out so that this angle right here is 30 degrees. Now, if that angle's 30 degrees, there, I know how much the hypotenuse is if I make a 30, 60, 90 triangle. If I bring this down, straight down, and put a right angle right there, then this angle up here is how much? 60. And what's the hypotenuse for this? X squared plus y squared equals 1, so all the radiuses are how much? Radius equals? Does everybody know the radius equals 1? X squared plus y squared, that's always your radius squared, right? So if the radius is equal to 1, the hypotenuse right here is equal to how much? 1. And if that hypotenuse is equal to 1, do I know what this side of the triangle is equal to? Do I know what this side of the triangle is equal to? Yeah, because if the hypotenuse is 1, it's what? Square root of 3 over 2 times 1. So it's just what? Square root of 3 over 2. That triangle is your first triangle. And all the people that have taken trig before, you start crying about everything you learn about triangles because they don't learn the first one. First one is based in geometry, 30, 60, 90. Now, if I ask you what the value was of that point right there, what is the x value and the y value for that point? What's the x value? Thank you. Thank you. Oh, I was about to say this is not a rhetorical question. Yeah, the x is how far it is out here, right? X measures from the y-axis out. Come on in. Did you get an admit? Okay, good deal. As long as you got an admit. Okay, out to there. Square root of 3 over 2. Is that good? Now, yeah, just set it in a different spot if you need to. Okay. Then, what is the y value at that point? 1/2. So there's the x value and there's the y value. Now, save that on your drawing, save that one, and make you another drawing that doesn't have the triangle in it. Leave that one to show how we got it, and then make you another drawing that just shows that. I'm going to put the point here. I'm going to put the 30 degrees like inside here, showing that's at an angle of 30 degrees up. And you got your admit, it's like 30 degrees up, right? Is that okay? I'm showing that that point right there is if I go up what? 30 degrees. And I'm going to go ahead and write in those values. Square root of 3 over 2, comma, 1/2. Now, just to go ahead and talk about it, and I'm gonna erase this, and I'm going to make my new triangle too. I don't really want to erase it. I hate to erase it. So everybody got that first triangle, and you see how it's laid out. Key is knowing what that one is, 30, 60, and the hypotenuse for every triangle that we draw in this circle is going to be 1. So everybody see how all the hypotenuses are going to be 1? All right. Now, what I'm going to do next is I'm going to simply take, and instead of going up 30 degrees like I just did for that one, and I can't keep writing 30 degrees in here, so I'm going to put the 30 kind of out there. No, I'm not even going to put it out there. I'll put it out there in a few minutes. But let's say we start here and we go up at 60 degrees. We make that angle 60 degrees. All right? Now, put your right angle here, and your hypotenuse is still 1. And I'm going to give you a chance to draw that real pretty on your paper. So you'll have all the information that we're creating. All the good stuff. That means this angle up here is now your what angle? 30. Which means this side down here is now what? 1/2, right? And this side over here, this long side is what? Which which means you can tell me the point value up here. What's the point value up there?
1/2.
All right, so we're going to go over here, and I made me a little mark for 60 degrees, and it's 1/2 comma square root of 3 over 2. So I know if I go up 30 degrees, that's my x value, that's my y value. If I go up 60 degrees, that's my x value, and that's my y value. And we do know the x and y here, that's what? 1, 0, 0, 1. What angle's between 30 and 60? 45. Now, we're going to do a little drawing for it. Usually I make a big drawing for this over there, but I don't know if it'll show up on the screen and all that. All right, 45. If this angle's 45 degrees, and I'll come down and make me a right angle. Notice how your right angle is always on the x-axis? Later on, we'll talk about that in trig. In trig, you always put your right angle on the x-axis. You never put your right angle on the y-axis. The right angle that you're going to be using in trig all the time is going to be on the x-axis. All right? Now, if that's 45, how much is this one?
45.
Now, and the hot news has to be 1. What do you know about the x side and the y side? Since those are 45 and 45 from geometry class. They're equal. Is everybody okay with that? X squared and x and y are equal. So, x squared plus y squared equals 1. But since they're equal, there we go, because y equals x at 45 degrees. Y equals x at 45 degrees. So we'll do that and we'll solve this. Somebody says, Mr. Evans, I didn't have to solve this because I learned my 45-degree angle rules in geometry. And if you learn the rules in geometry, you already know what the answer is. But let's go ahead and work it out. And you get 1 over 2, and x equals the square root of 1, square root of 2. All right. Now, square root of 1 is 1. So this point is 1 over the square root of 2, comma, 1 over the square root of 2. Now here's the scary part. I do not require you to rationalize. Just leave it 1 over the square root of 2. Okay, we'll fit that right here at 45. 45 degrees, 1 over square root of 2, comma, 1 over square root of 2. Now, somewhere on your paper, write 1 over the square root of 2 equals square root of 2 over 2 if you rationalize it. Because if you multiply by square root of 2 here and square root of 2 here, you'll get that. So if you're looking at one of the high school textbooks, you're probably going to see this. If you're looking at one of the college textbooks, you're probably going to see this. If you're looking at some textbooks, whoever wrote which chapter's answer key, some of the answer keys will leave this, some of them will leave that, according to which grad student was doing the answer key for the guy that wrote the book, or the woman that wrote the book, as in the case of Margaret Lyle. Okay? Dr. Margaret Lyle wrote a lot of textbooks for college students. But that's the key right there. This is the key beginning of trig. Now, someone in here has their calculator, and what I want you to do on your calculator is I want you to take your calculator and I want you to do cosine 0 degrees, cosine 30 degrees, cosine 45 degrees, cosine 60 degrees, and cosine 90 degrees. Make sure your calculator's in degrees. If you have one of the TI-84s, the default setting for it is radians, which we'll talk about eventually, but we're not there yet. Y'all think better in degrees to start off with. Tell me what you get.
The first one is 1.
Okay? Oh, and while you're doing this, some other group do sine of 0 degrees, sine of 30 degrees, sine of 45 degrees, sine of 60 degrees, and sine of 90 degrees. And the man's already told me that that one was what? 1. Okay? What's
30 is 0.866.
Okay, I'll live with that, because we're never going to use decimals in here, but we'll use it for this demo. And somebody do the sign.
45 is 0.707.
Okay? Cosine of 60.
Almost
Somebody's supposed to be helping him out doing some other ones. Sir?
there. 0.5
Which is just simply what?
at 1/2.
A half.
And then 90 is 0.
Okay, somebody help him out over here. What's the sign of 0?
0.
What's the sign of 30?
1.5.
What's the sign of 45?
Square root of 2.
Oh, square root of 2 over 2. Who said that? Did your calculator show you that?
That's what it's, yeah.
Yeah. 1 over square root of 2. Cool. Okay, do sine of 60 on your calculator.
I got square root of 3 over 2.
Square root of 3 over 2. And I'll go ahead and tell y'all, square root of 3 over 2 equals 0.866. 0.866 is square root of 3 over 2. And 0.707 is 1 over square root of 2 or square root of 2 over 2. And then somebody do the sine of 90 degrees. 1. What kind of calculator are you using?
TI-36X Pro.
Okay, it must be set to give you the actual exact answers.
Like, is it supposed to, should I be getting decimals?
No.
then, or-
No,
So this is good.
this is good. Okay, here's the catch. 0.866 is an approximation for the square root of 3 over 2. 0.707 is the approximate value of 1 over the square root of 2. But these are exact values. I like those much better. They're exact. And what's going to mess you up when you take test in trig is all the tests at the top say give answers in the exact values. Well, you use 0.707, you're not going to get the exact value. You have to use what? 1 over the square root of 2. Now, I made that list of numbers. I want you to look over here at your circle that we've been working on. The one that you've got that's got all the numbers on it nice and pretty. I want you to look at it and look at this list of numbers and tell me something. Yes, sir. Okay, the cosines.
For the circle, it's just the sign going down for the value.
Okay, the sine is 0.
For the x values.
Oh, which one's the x values?
Like on the sign, you see how the like the answer that you get, they're the same for the x values.
Okay, wait, 0.
No, start from the top. Sign 0
Top
is
right corner.
0. You see what I'm saying?
Oh, but let's start here, because 0 degrees is going to be here. Let's start 0 degrees here. Oh, you're thinking, yeah, y'all always make zeros straight up.
Mm-hmm.
We're going to start making zeros straight to the right. That's the reason physics is all wrong, because they measure everything from straight up, and it makes it harder. Okay? We're going to measure it from straight right, so keep talking to me though. Sine of 0.
I mean, it's just the y value now.
Oh, and this one is the x value. Folks, the key to this whole story is that the x value on this circle is always the cosine of theta, and the y value on this circle is always the sine of theta. Cosine on the circle is always the x value, the sine is always the y value. And that's where all of your trig comes from, this unit circle. All right? Now, so if I'm ever asking what is the cosine of an angle, I'm asking what would be the x value on that circle. That's where those values come from. Cosine, if you want to write a definition for it, is the x value at an angle on the unit circle. Do you really want to say that every time? No. So, forget that. Just say it's the cosine. Or it's the what? Sine. Now, the reason this is so important is y'all learned about similar triangles. Right? So the ratios stay the same no matter how far you go out on your similar triangle. See, this is always going to be half of h, right? So as long as that's 30 right there, the sine value is going to be 1/2. Now, somebody says, but Mr. Evans, we learned something different in geometry. We learned something about soaking our toes. Anybody remember something about soaking their toes? Okay. Y'all learned that the sine of an angle is opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse. And the tangent of an angle is the opposite over the adjacent. Well, folks, I want you to think about this. When I put the 1/2 here for the y value, what was the hypotenuse? 1, right? So yeah, every one of these values is over 1. So it works. That is still true. It's just when we use the unit circle, what does every hypotenuse value turn out to be? 1. And the opposite is the what? Y. Y over 1, x over 1. And then you're going to find out that the tangent is going to be your y value over your x value. Because the opposite value is always going to be the what? Y. And the adjacent is always going to be the cosine. Because that's going to always be your x. So, all right? Everybody getting the idea in the picture? See, this side right here, that's always going to be your adjacent. This side over here is going to be your what? Opposite. So everything you learn in geometry is true. And the deal was, when they taught it to you in geometry, they just taught it using the triangles, and they never associated it with x squared plus y squared equals 1. All right. Is everybody okay that you learned about this in algebra? That's an algebra concept, right? This is a geometry concept. So what did I just tell you that trig does? That's all it, yeah. It takes the geometry concepts and the algebra concepts and puts them together so that it's easier to use this at higher levels. You don't have to go back and break it down into smaller and smaller parts. You've got your unit circle, there's your algebra part, and then you've got your geometry. Now, this first quadrant is supposed to be known in your brain. When you say sine of 0, you're supposed to know it's 0. You see cosine of 0, you're supposed to know it's 1. You see cosine of 45 degrees, you're supposed to know it's 1 over the square root of 2. You see sine of 60 degrees, you're supposed to know it's square root of 3 over 2. That first quadrant has to be etched into the brain cells. Now, I'm going to show you something else that's kind of cool. The first law in trig, first trig law, the mother law. It's called the mother law in trig. Says that cosine squared of an angle plus sine squared of an angle equals 1. That's the mother law. How did the mother law, why does the mother law work?
X squared plus y squared equals 1.
X is the cosine value, and y is the sine value. Yeah, sine value is y. So basically this, the cosine of theta is the x value, the sine of theta is the what? Y value. So this mother law is just taking what you know from algebra, combining it with geometry to make the first trig law. And that's your first trig law. And we're going to talk about trig laws, and every time we talk about trig laws, for a whole bunch of them, we just go back to this. All right? A lot of those trig laws go back to that. So you can learn the first trig law, the mother law, and in trig they don't really call them laws. I'll go ahead and use the correct term. In trig they call them what's called an identity. Identity. In a trig they don't call it a law, they call it an identity. A mother identity, cosine squared theta. And why does that work? Because cosine is the x value and sine is the y value. And we based all this on the unit circle. Does anybody have a guess what all of these functions are called? We've taken something, we create a function that we've named, has a definition. It's okay if you don't know, you may have never already. These are called, I can't spell it, transcendental functions. Yeah, you're going to look it up, spell it right. I just spelled it really small up there so you can't really see it. Transcendental functions. And what happens is we didn't want to have to say the x value on the unit circle. We didn't want to have to say the y value on the unit circle. So we just shortened it. We gave it a short name. All right? Now, what I need you to do is you start memorizing this first quadrant